Good evening. Tonight we bring you this, the last of our Enterprise programs in our current season, direct on film from a conference room at the Sheffield Corporation, located on Springfield Street here in Dayton. This is a company that has been one of the older industrial residents of our community and one that is generally pretty well known in our community. But there's one particular aspect of this company's operation that is not perhaps as well known and understood as it deserves to be. This is a part of their company called the Eli Whitney Metrology Laboratory. To tell us about the Eli Whitney Metrology Laboratory, we have as our guest this evening Mr. Lewis F. Polk, President of the Sheffield Corporation, nearest me, and on your right, as you look at him, Colonel William Darmody, who is Assistant to the President. Welcome to Enterprise.
Delighted to be here.
Oh, Mr. Polk, there are some things perhaps about the name of this laboratory that I think we should clarify. First of all, what is metrology?
Well, Glenn, the Greeks had a word for it. When they referred to measurement, they said metro, and metrology, as we use it, means the science of measurement.
Well, okay, so much for metrology, but what about Eli Whitney? As I remember my school lessons, why, he was the inventor of the cotton gin.
That's right, and a very, very important contribution that was. It remade the industrial history of the South, no question about it. But by far his greatest contribution was his devising of a system of interchangeable manufacture based on dimensional control. It's about 1798 when he first got an order from the Congress of the United States for, I believe, 15,000 stands of arms. This is the original Eli Whitney rifle, and up to this time, every rifle was made by a craftsman by hand. No two rifles were alike, nor were their parts. The maintenance problem, the services at various, in battles, at the front, was a terrific problem. However, now for the first time, you were able to scatter the parts of 100 rifles or 10,000 rifles and pick up at random any of these parts, and they would make together into a fine rifle which would perform according to satisfactory standards.
Gee, that was a remarkable achievement for that
Tremendous
day.
accomplishment.
Well, I can see now the significance of the name of the laboratory. Let's turn for a moment to Colonel Darmody and ask him a little bit about the basic function and purpose, if you will, of the laboratory.
Well, Glenn, the basic function of the laboratory is to calibrate, standardize, and certify dimensions in the process of transferring the precision of our national standard of length to the products that we use in our everyday life and in the weapons we use for our national defense.
Well, in a moment, we'll come back and find out how some of these things are done and look at some pictures of parts of the laboratory. But right now, let's take time out for a word from our sponsor this evening, the Printing Service and Rapid Printing Companies. Tonight on Enterprise, we're bringing you the story of the Eli Whitney Metrology Laboratory. And our guests are Mr. Lewis F. Polk, President of the Sheffield Corporation, and next to him, Colonel William Darmody, U.S. Army retired, as I recall, Assistant to the President. As I told Colonel Darmody earlier, in Dayton, it's sort of unusual to find a U.S. Army retired rather than Air Force. They've already told us a little bit about what the laboratory does in the way of measuring for standardizing, calibrating, and certifying precision gauging equipment, I suppose primarily, for manufacture. But what are some of the actual manufactured products themselves that are checked for measurement standards here at the laboratory, Mr. Polk?
Well, two quick examples that are familiar to all of us, of course, would be the ball bearing. And occasionally we all have a little trouble with ball bearings, noise, and so on. I say occasionally because most ball bearings are mighty fine tools, a mighty fine piece of equipment. But when one occasionally does give us a little trouble, why, it's sent into this lab, and you'd be amazed as you look at the chart here to notice that instead of the perfect circularity, the perfect roundness that you would expect when you blow it up 10,000 times on the circularity measuring machine, it looks more like a cow track or a badly used gear.
Gee, that's amazing.
The crankshaft of a refrigerator, again, we should have expected a beautiful round bearing, but instead we have a very, very irregular shape. Now, the key here, of course, is that when you run into these infrequent troubles in manufacture, the problem is to locate the source of the trouble. So these troublesome parts are sent in, they're analyzed, and having located this trouble, to which I've just referred, it's a simple matter to change machining processes, or if necessary, part design to remedy the difficulties.
Mm-hmm. Well, Colonel Darmody, I have the impression that with this kind of precision exacting work, the laboratory probably involves rather rigid controls of conditions inside it.
Yes, actually, Glenn, I think we exceed the conditions that they use in an operating room for surgical cleanliness and temperature and things like that. Measurements, of course, are affected by temperature, humidity, and unclean conditions, and so we go to extreme lengths to keep those conditions under control or to compensate for them in where they are known, such as barometric pressure, which enters into some of our linear measurements.
I can imagine. I know we had an Enterprise guest, Mr. Ken Johnson, a few months ago, who told us about the importance of vibration. His company makes vibration control equipment. I suppose that's another problem you have here.
That is awfully important because, you know, in your speedometer of your car, if your needle was going back and forth like that, why, it'd be pretty hard to read it. So if we got vibrations, we can't read these very precise and delicate instruments that we use. And we have gone to extreme building conditions, such as separate foundations for the laboratory from the main building, so it's insulated from the vibrations of our heavy machine tools. And also, because of the extreme precision of our interferometers, we literally have them floating on air in what we call a pneumatic vibration attenuator.
Gee, that's remarkable, as well as a little overpowering for a layman like me. Another thing that is an obvious impression, to me at least, is that this, Mr. Polk, must require a substantial investment.
Well, that's very true, Glenn, but of course, beyond the finance or beyond the money, the real investment is in the contribution that has been made over the years by hundreds of Sheffielders and their dedicated approach to this type of work. This has been augmented, of course, by their counterparts in Switzerland, in Germany, in France, in England, where we refer to the National Physical Laboratory rather than laboratory, as we say in our land. And then, of course, by no means the least, even though I mentioned them last, our great Bureau of Standards at Washington. All these people have made an investment in their time, in their energies, in their vision, and their imagination in helping us create this Eli Whitney Laboratory.
Thank you very much, Mr. Polk, Colonel Darmody, for being interesting and charming hosts here in your plant this afternoon for our Enterprise story.
Thank you for the opportunity to be with you.
Again, we've brought you an Enterprise story of a Dayton manufacturing company. A company that, like many others in Dayton, takes the outreach of our community literally around the world. A company whose Eli Whitney Metrology Laboratory, among other contributions, makes it possible for other manufacturers in other communities and of all kinds around the world to make better products for us all.